Hi and welcome to this Ignite webcast. My name is Josh Topal and I work on the Office 365 team. And if this is your first time, Ignite events are a series of technical workshops for IT pros and Microsoft partners. And these Ignite webcasts will address different technical subjects and scenarios that are really beneficial to anyone who wants to increase their knowledge of the Office 365 suite. So today we're excited to welcome back Brian Day. Brian has done a few sessions for us, and he is a senior program manager from the Exchange Customer Adoption team. So in today's webcast, Brian will be introducing us to the new Exchange Server 2013 architecture. And today's session really provides a great opportunity to hear directly from someone that works so closely with Exchange on the Office 365 team. So today's webcast will be about an hour, and we're going to leave a few minutes at the end to field your questions. And so you can type your questions into that linked chat box. I recommend that you do hold them till the end when we do have our Q&A portion. One last thing is that we are recording today's session, and we'll have this recording and the PowerPoint that you're seeing here on the original blog post and on the Ignite site. So let me go ahead and paste those in right there into the chat window. And one thing I do have to mention is that since we are recording today's session, please understand that you may be captured in today's recording. So if you don't wish to be captured, then please don't type anything into the IM window, or if you want to be extra safe, feel free to leave the meeting and you can view the video recording at those links at a future time. So that's it for me. So Brian, whenever you're ready.
Thanks, Josh, for the handoff. Welcome, everybody. Looks like a pretty good crowd today. And as we go through this presentation, which there's quite a good number of slides, so we might go through some of them a bit quickly so we can get to Q&A at the end. I am not paying attention to the IM window, so if you think that I'm ignoring you, I am not. I do see a number of veteran Microsoft employees from Exchange Land over in the attendees list, so maybe they'll help out with some of the during meeting Q&A, because I know how hard it is sometimes to hold on to the end. But we'll get going. So with that, welcome to Exchange Architecture. Some of you may have seen this presentation in maybe some of the Ignite deliveries we've delivered in various countries and cities around the world. If so, this might be a little bit of a repeat for you. For those of you that this is new, welcome, and we hope that we can give you a pretty good kind of high-level, mid-level overview of what Exchange Server 2013 looks like today. So some of the things that we'll cover will be the client access server role, the mailbox server role, and then finally we'll wrap up with service availability changes in the product itself. So to start off, we'll hit up the client access server role, or the CAS, as we all love to call it. It is still a domain joined machine in your internal Active Directory forest. We do not support the client access server role being out in a perimeter network, or DMZ if you want to call it, that is joined to a different Active Directory, perhaps management forest from your other Exchange servers. They must still be in the same forest as your mailbox servers. We consider the CAS role now to be something, as you see there, a thin stateless protocol session server. A lot of the processes that we had on the CAS in earlier versions of Exchange, for example, in 2010, where all the MAP-RPC connections were made, had been moved back to the mailbox server role. I'm not sure, I don't think we have a deck in this particular, a slide in this particular deck where we actually talk about how we've removed a lot of the roles that you've become used to in Exchange 2007 and 10. So as you see throughout this presentation, we're only going to be talking about two roles, CAS and mailbox. All the other roles are gone. The functionality is still there, but primarily, if you don't hear me talk about certain things in this CAS section, they've all been moved to mailbox, which we'll get to in a few slides. So continuing on, the CAS role itself, it has three components primarily. So we've got our client access protocols, where that's HTTP, IMAP, POP, etc., that a client would be using to get access to different resources. SMTP for sending, receiving mail through the CAS, and also what we call the UM call router, which we'll talk about in a little bit. It's essentially an Exchange-aware proxy server. So as all the connections come into CAS, CAS is now understanding all the different protocols, and when it does an authentication and looks up your mailbox location, whether on Exchange 2007 or Exchange 2010 or Exchange 2013, it then determines, what do I have to do? Do I need to proxy this connection back to a legacy server, or proxy it to a different Active Directory site? Are we going to do a redirection so that this user gets the best access by getting them to a CAS that is closer to where their mailbox is currently mounted? Excuse me. Some people actually have refer to the new CAS role as almost being a hardware load balancer, and it almost to some degree is, but you'll actually see that we do have recommendations still for keeping hardware load balancers in your environment. Can somebody just give me a quick mic check? My link just flashed here like it lost me.
Yeah, I can hear you.
All right, thank you. Here. So let's talk a little bit about what a client access would look like when it starts to come into Exchange 2013 environment. You'll see that we do have a load balancer there on the top. The darker gray bar kind of in the middle where you see IIS, HTTP proxy, POP IMAP, etc., that is the logical representation of a client access server. The lower portion in the lighter gray box where you see IIS, RPS, RPC proxy, etc., that is a representation of the mailbox server role, which we have not talked about yet. So, the majority of our protocols that you're all familiar with, Outlook Web App, Outlook, ActiveSync, Exchange Admin Center, what used to be called ECP in 2010, and also Remote PowerShell. All of these guys would come through your load balancer, and we'll talk a little bit later about how the load balancer in 2013 is actually no longer necessary to have a layer 7 load balancer. Now, you could still utilize one. There are some scenarios where it might make sense depending on your particular deployment at a company. But you can actually get away with a layer 4 load balancer that is simply keeping TCP session affinity and no longer doing any sort of crazy SSL ID or cookie tracking to make sure that you're doing a layer 7 affinity. So these connections would come into IIS, they would hit the HTTP proxy on the CAS, and what would then happen on the back end is the CAS would take a look at that connection, authenticate the connection to make sure that you are a valid user, determine what version of Exchange you're on to determine proxy and redirect logic, and then also determine where your mailbox is currently mounted. So let's just say that this CAS and this mailbox server were in the same Active Directory site, and this user was a 2013 user mounted on the database that is in the lower portion of the screen. So their connection comes in, hits IIS on the CAS, we then proxy over HTTP, not RPC, back to IIS on what we call the backend website for the mailbox server role, and then the connection would be split out amongst the various client access protocols depending on what kind of connection it was that came into Exchange. A little more on that later. POP and IMAP, same thing. They would hit a load balance name that then hits one of your CAS in the site, hits the POP and IMAP services on the CAS, and then proxies back to POP and IMAP on the mailbox server. As you can see here, yep, I'm going to repeat for SMTP. Same thing. The message comes in, hits SMTP on the CAS, and then is proxied back to the mailbox server's transport services, which we'll go into much more detail later. One thing I do want to make sure we mention right now before we go any further is that there is no storage of SMTP traffic on the CAS. There is no mail.queue on CAS. All those messages, we'll talk about a service called the Frontend Transport service in a little bit. All those messages simply proxy through. There is no storage of mail on the CAS itself. All of that is done on the mailbox server. And we'll talk about how we do that and also how we make sure transport is redundant when we get to the mailbox role. Now, we always have to have one child that's a little different in Exchange. Exchange 2010, it was probably our public folder connections, but we've cleaned that up and decided that would be our special child in Exchange 2013. So, if a message comes in from your telephony environment, you would hit SIP on the call router service on CAS. You would then be issued a redirect, and it might be a little hard to see there. It's a little light gray line, but your SIP and RTP connection would then be made directly to the unified messaging service on the mailbox server itself. So that is the only time that a client would actually reach directly to the mailbox server in 2013. Now, generally speaking, it's not really going to be a client per se, but your internal telephony systems, whether they be Link 2013 or something else that are making that direct connection. So you really won't have clients themselves, the end user client devices, making any direct connections to Mailbox. One of the excellent things that we've done is we've actually gotten rid of direct MAPI RPC or RPC connections directly to the client access server or the mailbox server. As you know, in 2010, we moved RPC connections out to CAS, and in 2013, we've just gotten rid of them. Now, don't be confused. We've had a lot of people say that we've gotten rid of MAPI. MAPI is actually still under the covers. We've just simply changed what transport mechanism we're using to connect via. So in 2010, we used MAPI RPC directly, but we also supported Outlook Anywhere as we did in earlier versions of Exchange. That is exactly what we're doing here. We only support RPC over HTTP, not direct RPC connections to Exchange. The glorious part about this is that we've gotten rid of essentially a very latency intolerant protocol. So now we have a lot more options on our hands as far as site-to-site connectivity, trying to help you guys get rid of those terrible little Outlook pop-ups about waiting for an Exchange server to respond. And by moving to HTTP only connections, we've been able to do that. And it's far more reliable and far more stable, we found, by going that route and getting rid of the RPC direct connections entirely. As you can see below there, we've also eliminated the RPC CAS array object namespaces. So you're no longer going to have to create those new -client access server arrays per Active Directory site. That was a one and done in 2010. We've gotten rid of that in 2013. And also by moving to this model, which we'll show you how a little later, we've also gotten rid of another one of the reasons that you might get that little nasty pop-up that says the Exchange admin has made a change, please quit and restart Outlook. And any time that we've had a switchover or a failover, or as we tend to call them, a star-over event. Also to this move, we've made namespace simplification a huge deal. So in 2010, we probably made a lot of you guys, become certificate experts because you had a namespace for OA and ActiveSync, etc. You may have had a different namespace for Outlook Anywhere, depending on the authentication types you were using. You also had your failback URLs, your auto-discover URL, your site-specific data center URLs. You could have a lot of names on a certificate, especially if you're a company that's purchased other companies. You still have their SMTP domains in your environment. The certificates could get quite large, quite long, and with a lot of different alternate names on them. We've actually made it to the point where you can even, if it makes sense for you, use a single namespace worldwide. So you might only have an auto-discover name and then a single access URL, mail.contoso.com, etc. And this also works with Exchange 2010. And we're going to show you what that common namespace example looks like. Now, before I move to that slide, this is not saying that every customer is expected to go this way. This is just another option that is out there for you to consider that was not a possibility in the past. You might still have data center specific names in your environment, and that is perfectly fine and will work just like it did in 2010. Okay, so let's show what that would look like. We have our famous contoso.com organization. We have what is represented as 4 data centers on the lower part of the screen. So the 2 blues on the left and the 2 reds on the right. The 2 blue ones are in North America. The 2 reddish-orange ones are in Asia Pacific. We are using the single name mail.contoso.com across all of our data centers. In each of our data centers, we have a virtual IP, which would be a load balancer or a pair of redundant load balancers for high availability. And we also have client access servers, which are the boxes with the little round person's head next to it. And then at the bottom, we see we have a DAG that spans North America data centers and a DAG that spans the Asia Pacific data centers. They do not cross all 4 data centers. So we've got our user, Sue. She's somewhere in North America, and you can see down on the bottom left that the other little Sue icon represents where her mailbox is mounted, which is currently in the far left data center in North America. So geographical DNS. If you're not aware, she would make a DNS resolution request, and GeoDNS would say, oh, we see Sue's request coming from this IP block, and we know based on a industry standard IP database that that IP block is somewhere in North America. We might even be able to say it's on the west coast or the east coast of North America. And in this case, Contoso's DNS is configured to do a round robin. Right, we're either going to give you a virtual IP number 1 from one of the North American data centers or a virtual IP number 2 from the other North American data center. In this particular example, we don't care because Sue's in North America. We've got good connectivity to all those locations. Contoso just says it's okay if she goes to either one, and we'll just round robin our load between the 2 sites. So in this case, let's say that Sue got virtual IP number 1. Well, she just so happens to hit the client access server array that is in the location where her mailbox is mounted. Simple, right? This is the best case scenario. She gets the VIP back for the data center that her mailbox is in. She hits CAS, and she goes right to her mailbox server. So let's change it up a little bit. Perhaps, she was the second person to do this request and gets the round robin IP to VIP2. Well, if you really pay attention, you'll notice something's changed here. In 2010, we would have gone from the CAS and VIP2's site to the CAS and VIP1 site. We're no longer doing that. We're simply going direct from CAS and site number 2 to mailbox in site number 1, and we'll be doing that via HTTP, not RPC. So it's not that we don't care, but latency is not as much of a factor as it was between the sites before. So moving on to another example. Let's say Sue's somebody who travels for her position at work. So Contoso sends Sue over to Asia Pacific to meet up with their Asian Pacific offices and do some meetings over there that are better handled face to face. Well, now what happens is if Sue does another lookup via geographical DNS, what's going to happen? She's going to get back one of the IPs for either sites 3 or 4. Right? She's no longer going to be sent all the way across the public internet to sites 1 and 2 in North America. Their GeoDNS has realized that while Sue's sitting in APAC, it's much better to send them to an APAC data center, and then we'll let them proxy across, because perhaps our WAN infrastructure is much lower latency and better bandwidth than she would have gotten going over the public internet from that location. So example number 1, we'll say she got VIP2, she hits the load balancers there, the client access server is there, and we do a long haul proxy across the 2 different sites back to the same site where she was mounted before. Again, we go direct from CAS to mailbox, and we use HTTPS between the servers, not RPC. As you can imagine, it was possible she could have gotten VIP3. Same thing. We hit the CAS in the data center in Asia Pacific on VIP3. We proxy via HTTPS back to the same set of mailbox servers, or I should say the mailbox server where her mailbox is currently mounted. Okay, hopefully that's relatively straightforward so far. Again, merely an example. There's no reason why you can't still do a mail.contoso.com that points to, let's say, North America, and an apac.mail.contoso.com that points to Asia Pacific. Perfectly fine to do that. This is just something new that we now have the option of doing, because we do proxy directly across the sites from CAS to mailbox, no longer CAS to mailbox. You must take into consideration, like say this example here, is the WAN bandwidth able to sustain user connections being proxied between the data centers, or does the company prefer to use the public internet? If they prefer to use the public internet for redirection, because the interior network can't handle a proxy, maybe we'll just do data center specific names. If they really don't care, then they can do GeoDNS to focus their traffic to particular data centers, depending on where the resolution request comes from, or just use round robin if they've got a couple data centers in the same area. Just another option, not a you should have to do it this way. The third-party MAPI products, since we've gotten rid of direct MAPI connections, what do they do? Well, they need to use Outlook Anywhere. So what we've done is we've made a release for the MAPI CDO download package that actually enables an in-between for third-party products to install on their servers, and they can simply do Outlook Anywhere connections from, let's just say, because it's an extremely popular solution, Bez, right? So BlackBerry's Bez server. They could install this new MAPI CDO package, and BlackBerry could tell you what version of Bez you would need that supports this new package, and then that server would be able to make Outlook Anywhere connections over RPC over HTTP instead of MAPI RPC directly. Now, this is going to be the last update to the MAPI CDO package we have. The direction we're asking third parties to move is Exchange Web Services for all things in third party down the road. The support for the MAPI CDO package is actually tied to Exchange Server 2003, which goes out of support in April of 2014. So the MAPI CDO package actually has its support expire next April. So we're already starting to see a number of our partners and ISVs move towards the Outlook Anywhere connection, and we're very happy to see that. So a little bit more about client connectivity flow. In this example here, we see our layer 4 load balancer, and a client connection comes in HTTP. And I want to be very clear that when we say a layer 4 load balancer, this does not mean you need to do IP affinity, right? We don't care about source IP so much. When it says layer 4, it's just meaning that we're going to make sure that TCP sessions are held on the same CAS, but I could have a program like Outlook Connect with Outlook Anywhere that makes a various number of TCP sessions. All those TCP sessions could be sprayed across a number of CAS, and that's perfectly fine. We don't need to say, oh, all connections from 192.168.1.1 have to go to this CAS. That is no longer a requirement for 2013. So client connection comes in, hits HTTP, we hit our layer 4 load balancer, we hit IIS on CAS. If this is the CAS in the same Active Directory site as the mailbox server that their mailbox is mounted in, we'll simply do another HTTP, or really HTTPS, right? It's the secured HTTP connection to the mailbox server, local proxy request. All right. If, let's say, and maybe we'll say this is OA, let's say our connection comes in. We've added another Active Directory site here, same exact Exchange 2013 setup in our different ADA site. The connection would come in, and the first thing that we would do is look to see, well, is there an external URL configured for OA in the other Active Directory site? If there is, we simply do a redirect, right? This idea is not too foreign. We've done this in previous versions of Exchange. And we'd redirect that connection to client back to IIS in the other Active Directory site and proxy down to the mailbox server there. If there was no external URL, we would have done what we did before. I believe we have that coming up right now. So we have an HTTP connection come in. Let's say it's OA. We look to see, okay, was there an external URL for OA in the Active Directory site that the mailbox is currently mounted in? No, there is not. So our CAS is an HTTP proxy across the site boundary directly to the protocol head on the mailbox server in the other site. Now, early versions of this presentation didn't have that CAS listed in the other site. And that was simply to show that we didn't utilize it in this particular logic, protocol logic. We do still require CAS to be in every single site that you have a mailbox server. Because let's say you had users in that site. Well, they'd be accessing their mailbox via that CAS. And if that CAS goes down, what good is it even having a mailbox server in that site? There are various other scenarios, but that's the primary one that we bring up. Okay, now let's look at a little bit of legacy coexistence with Exchange 2010. So directly in the middle, we see CAS 2013 and Mailbox 2013. I also want to bring out that we're showing all these at a logical layer. Microsoft currently recommends that Exchange Server 2013 be a multi-role server, CAS and Mailbox on the same server itself. But for example purposes, it is much easier for us to show you the different layers from a logical format instead of trying to show CAS and Mailbox on the same box in a PowerPoint slide. So we've got 2013 down the middle, 2010 off to the left in the same AD site, and also 2010 off to the right in a different Active Directory site. So let's do the same thing. Client connection comes in, we hit our layer 4 load balancer, we hit IIS on the CAS 2013, and in this case, we'll then hit HTTP proxy and hit the protocol head on 2010 CAS. We will not go directly CAS 2013 to Mailbox 2010. That is not allowed. We must go through CAS 2010 first. And then, because this is what it's always used, CAS 2010 uses RPC to connect to store on the 2010 mailbox server. Okay, not too much different there, kind of what you'd expect. So let's change it again. Let's have our connection come in. We'll hit that same layer 4 load balancer. We hit IIS on the 2013 again. But in this case, we see that we've moved the user's mailbox over to the right-hand side. So now it is in the different Active Directory site. So in this case, we do our lookup. Let's say it's OA again. We see that there is no external URL set for OA, so we'll do a proxy directly from CAS 2013 to CAS 2010. CAS 2010 does this RPC connection, and we're good to go. We've got our connection made. Well, what if we did have an external URL over there? We see we have our layer 7 load balancer from ye old Exchange 2010 days. So we'll have our connection come in, hit CAS 2013. Our mailbox is still mounted in the other Active Directory site, but this time we see we do have an external URL value set. So we'll do a redirect. It'll be redirected to the layer 7 load balancer. Hit the protocol head in CAS 2010, mailbox server 2010 via RPC, as you'd expect. Now I've got a nice eye chart coming up for you. I'm not going to go through every single thing here, but you will get this as part of the presentation that Josh mentioned you can download later. This has been slightly updated, so this is as of cumulative update 2. So I'll point out, let's see if my little highlighter here works. Let's do the laser pointer. So if you guys can see this, we've now updated this to say CU2 plus. We now have silent redirect with silent single sign-on for any Exchange 2007 user accessing 2013 namespace, or even a 2010 user accessing the 2013 namespace where it needed to be redirected. If it was a proxy, this wasn't a problem before, but in redirections, you used to get that screen that said, I'm sorry, you need to go to this URL, and they'd have to log in a second time. As long as you're deploying CU2 or later, we've brought back the same silent single sign-on logic that we had in Exchange 2010, where if you're using forms-based authentication on both sides, being handled by Exchange, not by something like TMG, we will do that silent single sign-on for the users. Also interesting to point out is that when you're using ActiveSync, a 2007 user, we will actually proxy not from CAS 2013 to CAS 2007. We first go CAS 2013 to Mailbox 2013, back to CAS 2007, back to Mailbox 2007. So keep this in mind. So even if you just install 2013 CAS and Mailbox, because you need both before you can manage anything on 2013, if you then go and say, oh, that 2013 Mailbox server is just there for, for giggles, and turn it off, and you've moved your namespace thinking, oh, I don't have any mailboxes on 2013 yet, I can just turn that off and do some maintenance, you would break 2007 ActiveSync users by doing that. So be aware of the fact that we proxy to Mailbox 2013 first for 2007 ActiveSync devices. All right, moving on. I just want to go back real quickly. The point of this chart is to show you if you've got 2010 in the environment, we're proxying in almost every single scenario. When it comes to 2007, we do have legacy namespace redirect for, excuse me, OA, and you also have to have a legacy namespace out there for EWS, since that is version specific. So if you're using 2007 in your environment, you will need to have a legacy URL similar to Exchange 2010. Split DNS, we still recommend split DNS. It makes it very easy to have the same namespace internally and externally. You just have different IPs on the inside or the outside. But we do allow you to actually have different Outlook Anywhere proxy names if you want to. For maybe internally you're using a different authentication type than externally. You could have a outlook.contoso.com internally and let's call it external.outlook.contoso.com used for external connections if you want to use different authentication types for your Outlook Anywhere, depending on if the users are inside or outside. Outlook will always try the internal proxy first, and then if it can't reach it, it assumes, hey, can't reach it, I must be on the outside, I'll use my external settings. So a quick wrap up of the new architecture so far is that we have greatly simplified the network layer. We're essentially using HTTP everywhere. We're not using RPC for any of our proxy connections any longer, or CAS to mailbox connections, making latency not as much of an issue as it was in the past. We've gotten rid of the RPC CAS array entirely, so we don't have to set those up anymore, and we don't have any Outlook profiles updating when you move a database between sites perhaps, and causing users to have to restart Outlook. And our deployment flexibility goes up greatly. There's a lot of work that we're doing in future updates of 2013 to try to make sure that when you're doing, let's say, cumulative update installs, that it doesn't really matter as much if we update our mailbox first or our CAS first. This is some of the work that's gone into the infrastructure, so you don't have to worry about the old way of updating Exchange servers any longer. So let's talk about FETS, Frontend Transport Service. So FET sits on CAS. As mentioned, it is the first thing that takes a look at SMTP traffic as it comes in. It is not storing anything. There's no mail.queue there. The only thing it is doing is looking at all the mail headers of this message as it comes in. So it has full access to the protocol layer, the protocol conversation, as we say there. And we'll kind of take a look and say, okay, well, who is this message bound for, right? So we'll look at the first 20 or so users and figure out, are these users in a DAG? Are they non-mailbox enabled users? Are they just a bunch of distribution groups? What are we going to do in our next step? So it takes a look at that after the messages come in and decides what I need to do with it later, and we'll talk about that. As stated, there is no mail queued locally. It's completely stateless. And you can also make outbound traffic route through your CAS if you want to. If you want to kind of consolidate the number of servers making connections outbound, you can make all your mail flow through the CAS in the outbound direction. We've got our normal TCP 25 and TCP 587 receive connectors in place, as we always do, so those will be there by default. And we'll take a look at what the pipeline flow is. So we got our front-end transport pipeline listening on CAS. We have an external SMTP connection come in. Now, external SMTP to us means something outside of the Exchange org, right? This could be a SharePoint server sending in to Exchange that actually is, inside the corporate network, but it's outside the Exchange org itself. This could be internet mail that's coming inbound, something that is not Exchange. So it comes in, it hits our SMTP receive event, Our protocol agents will take a look at the message to determine, well, what do we need to do with this thing based on the recipients. Once it makes that determination for routing, send it off to SMTP send, which then determines what Mailbox 2013 server to send it to next. Again, mail's not proxied here. It is mail's not stored here. It is a proxy end-to-end. The message will never be stored on the CAS role. So if you had a CAS dedicated server without Mailbox on it, the message will never be stored there. Very similar to SMTP from Mailbox 2013. So Mailbox 2013, we use SMTP to send messages up to the front-end transport pipeline for outbound. CAS 2013 then determines, well, based on this message, where is the next place it needs to go? Based on our send connector configurations, when we send this out SMTP send, where is it going to go? What's the next hop going to be? A smart host? Or is it going to use DNS first to look up? What do we need to do? Entry point routing. So this is when FET gets the message and it finally makes that determination. Well, what are some of the things that we're looking at? First of all, we do not bifurcate on FET. Right, so we will not split the message into multiple messages on the front-end transport layer itself. We will send a single message on to the next location, what we consider the best next hop. So we use something called delivery groups to determine what that best next hop is. A DAG is considered a delivery group. Now, this does not mean that it has to be the Mailbox server with the database mounted for that recipient. It can be any server in the DAG. So a message might hit CAS in site B for some reason. Maybe you've got multiple MX records for different sites weighted the same. Message comes in, hits site B. FET will say, hey, I've got messages bound for a mailbox in DAG 1. Do I have a mailbox server that is a member of DAG 1 here? Oh, I do. Great. Just send it there. That's fine. And then we'll let that mailbox server replicate. Then send the message off to the server that has the mailbox database mounted on the other site, and they'll take care of all their own mailbox replication, etc. Mailbox, if it is not a DAG member, mailbox server, I believe I should say, or AD site if we have to fall back for legacy routing 2007 and 2010. All right, so it depends also on what kind of recipient type. Is it a single mailbox recipient? Is there a delivery group for DAG members in there? Is it a non-mailbox recipient, right? So distribution group, a mail-enabled user, etc. Or we just pick a random mailbox 2013 in the local site. Preferred, if there's none, we'll pick just a random one based on AD site cost. And FET is really just deciding the next best hop. That's all it's really doing in the end. Anybody that's had a chance to listen to, let's say, Brian Reed, who teaches or taught, the NCSM and MCM classes, you know how much he can do 2, 3, 4 days worth of routing talk. There's a lot that FET can do. And I believe we also have some excellent transport presentations that either have already been given or are about to be given that will get into this much deeper. SMTP mail flow, inbound and out. This is what we were looking at earlier, so we'll go through this pretty quickly. FET accepts the initial SMTP conversation, right? So if the source is good, we'll bring that message in. We then determine where are we going to send it based on the recipient, right? Where's the next best hop? And then we proxy that message off to the best mailbox server that there is. Outbound, we're only going to see outbound mail if we see that front-end proxy enabled is turned to true on the send connector. So if the send connector is set to true, the mailbox server gets the message, says, hey, we're going to send this message out via this send connector. Oop, this parameter is set to true. I need to find some CAS in the same ED site as the source servers, and then proxy that message out through CAS because of front-end proxy enabled. And then you will, on the alternate side, the receiving side of the message, you'll see the message coming to you like it came from CAS 2013. All right. Some of the new benefits of the front-end service for SMTP, network protection, right? So we were able to consolidate down to the CAS, which you have much fewer of than Mailbox, where messages are going to egress from the organization. The mailbox locator determines the best 2013 mailbox to deliver to. We don't have a large number of unnecessary hops as we did in 2010, where we'd actually send the mailbox to 2 different servers to create a shadow copy. We'll actually just send it off to the best 2013 mailbox server first, and then let that server deal with shadow copies and safety net. And also gives you a very easy load balance solution for client and application SMTP listeners, which you can do in 2010, and we've carried that forward. All right, mailbox server role. This is the beefy one. If we have not talked about it yet, Mailbox does it. This is where the majority of your transport has moved to. Unified messaging has moved here. All of your OA rendering has moved here, and we'll go through that right now. Okay, so all the rendering, as I just mentioned, done on the Mailbox server role. We've moved that out of CAS and back to Mailbox. Why have we done that? Well, over the years, we used to be, back in Exchange 2003 days, let's say, we were very memory bound, right? We didn't have enough memory to do the things we wanted to, so we went to 64-bit in 2007, had plenty of memory, but still CPU power wasn't that great at the time, so we had to split out into all the various roles. 2010 came around, we now had still uber amounts of memory available. We now had high numbers of cores for CPUs, and that's where you saw Microsoft start to move towards the recommendation of doing the multi-role servers, bring all the processing back to this one single server with all the roles on it because we were no longer CPU bound. And that is why in 2013 you also see us continue that by moving the processes back underneath the Mailbox server role itself, because we now have lots of memory and lots of CPU power available to us in a two-socket system, which is really what we still see as the sweet spot for Exchange. Very easy to get, 16 physical cores in a two-socket system today. We're back in 2007, you might have gotten 4 cores at the beginning of when 2007 came out in 2 sockets. Again, only client access servers except for with RTP and SIP connections directly to CAS. Again, call router will redirect your telephony system back to the Mailbox server itself. We don't allow crosstalk between Mailbox servers. So if Transport wants to put a message into a database on a different Mailbox server, we no longer allow it. We don't allow protocol crosstalk. So we will require, in that example, Hub Transport on server 1 to send the message to Transport on server 2, and then let Transport and Store handle getting that message into the database on server 2. We do not allow, let's say, any of the client access protocols, whether it's OA or ActiveSync or Transport on one server to talk into Store on another server. Again, making deployment flexibility and upgrading a much easier experience, because now we only have to make sure our protocols at the protocol head layer understand how to talk to each other. We don't have to worry about changes in Store so much between different versions. We continue the DAG idea. A DAG still contains anywhere from 1 to 16 Mailbox servers. Yes, even if you're running on Server 2012 or Server 2012 R2, once we start to support it, we're still limiting you to 16 Mailbox servers and a DAG. If you've not used Exchange 2010 before, the DAG is a replication boundary for where your databases can be replicated. So you cannot have 2 different DAGs and replicate databases between those DAGs. Replicas can only stay within that DAG itself. And DAG members still can be different members of different Active Directory sites. That is fine. And let's go into some of the things here that have changed. So let's talk about Managed Store. Again, reduction of IOPS, larger Mailbox support, public folders, and the new search infrastructure. Managed Store. So a lot of what you see in 2013 are lessons from Office 365. How can we isolate failure zones within the data center to make sure that when we do have problems happen, because they will, software is never perfect no matter what anybody tells you, how do we react and recover as fast as possible while affecting the fewest number of users? So Store, even going back to Exchange 4 or 5 days, has always been this single large monolithic process that everybody thought had a memory leak because it used all the memory on the server. So we have now broken it up into a controller process and a worker process. What you'll now see is that an Exchange 2013 server has one controller service, and you can see there it's Microsoft.exchange.store.service.exe because it is now a .NET written process. We've moved away from legacy unmanaged code, and we will then have a worker process that is one per database. So if you have 50 database copies on your server, you'll see one controller process and 50 worker processes. So now if we have a problem where, let's say you have a poison message that crashes the worker process for a particular database, we'll only have to restart that database instead of restarting every database on the server, which in the past would have affected every single user. So the controller service is in charge of handling the worker processes, telling them what to do, terminating them if they see a dirty dismount during failover, logs all the failures into the various components on the system, and manages dismounting and mounting on the worker processes. Worker processes, each one will have a different RPC endpoint. So when your CAS is trying to make a connection back to the Mailbox server via RPC over HTTP, once we go through the RPC over HTTP proxy on the Mailbox server. They'll be connecting to various different RPC endpoints depending on which database the connection is bound for. The worker process is responsible for block mode replication for passive databases, right? So we still have the idea of file mode and block mode replication as we did in 2010. Each individual worker process is in control of making sure that we're going in and out of block mode replication as necessary. You will also see that a worker process uses approximately 20% of the memory that an active process does. So if you have a server with a large number of database copies, maybe you have 20 of them, but you've scaled your system so that only 10 of them can be mounted at any one time for performance reasons, you'll see that you'll always have, even in the worst case scenario, 10 passive copies that are using a much smaller amount of memory than they used to. Now, layered on top of managed store, we still have the MS Exchange REPL-EXE process. This process here is the one that is responsible for detecting unexpected database failures. It will then issue mount and dismount operations to store. Now, what this actually means is it'll send a command off to the controller process of store saying, hey, I want this particular database instance to dismount. And then the controller process of store will then tell the worker process, hey, buddy, you need to dismount because we got a request from the replication service. This is also all of your admin interface. So when you issue a command from PowerShell, it is actually going to go and tell the replication service what you want to be done, which then, in the dismount or mount case, will then tell the controller process tells the worker process, and so on and so on. For managed availability, which we've not spoken about yet, this is the process that is responsible for initiating failures or failovers and taking care of what store and responders of managed availability have told it what it needs to do. Cache management, and it's going to be shown graphically in the next few slides, but essentially ESC cache management is still going to use a heck of a lot of memory on your server. Expect to see Exchange, even on a server without any mailboxes, using a lot of memory. Okay, what you're going to see is that the controller process is going to use a finite amount of memory. The store process overhead itself is going to use a finite amount of memory, and then all of your worker processes are going to vary a bit. They're going to kind of go from 20% of what we call their max cache target when they're passive up to 100% of their cache target when they're active. And I will show you what this looks like. But a quick warning, if you add or remove copies of databases on a server, you must restart the store service before the cache algorithm will update itself. So if you have 10 database copies on a server today and you add 4 more tomorrow, restart store. It only looks at the number of database copies on the server at process startup time. So if we try to put this in a graphical example, and this is not perfect, this is just to get you an idea of what you might see if you look in Task Manager. Let's say we had a system with 100 gigs of memory. We would expect the total ESC cache to use 25% of system memory. That is a hard-coded number. So you'll see that the ESC cache use a total of approximately 25 gigabytes. It'll go up and down a little bit, but about 25%. Search Foundations, that we'll talk about later, also uses about 25% on what we call a fully loaded box, which means all your mailboxes are fully loaded, all the items you expect are in there, they've all been indexed by Search Foundations. We expect that to be roughly about another 25%. Again, could vary up and down a little bit, but in the area. And then there's everything else is going to use the rest of the memory in the box. IIS, antivirus scanners, backup agents, whatever. The other roughly half is there for everything else on the server. So in this case, we've got 10 active databases, 0 passive databases, and we've configured the server to allow 10 max active databases, which in this case is looks a little silly, but it's for example because we only have 10 copies. So that roughly 25 gigs of memory gets split up 10 ways. You can see each one gets about 2.5 gigs of RAM. So that's for each database copy on the box. Well, what if this server didn't have 10 active database copies? Let's say it only had about 5. Well, what you'd see is that the active ones, again, they still get about 2.5-ish gigs of memory. But as we mentioned before, passive copies use about 20% of their target. So we can see that the passive copies use about 500 megs of memory. And then if you were to activate them, they'd blow it up to about 2.5 gigs each. Now you can see that remaining pool there, that kind of 14 gigs. That's not like set aside for something to use, but we will actively pull it into the database copies if they get activated. Now, the most interesting example is this one. Let's say you've got 5 active databases, 5 passive databases, and you're configured your server for 5 max active databases to be allowed. So this means you've probably already got a server failure somewhere, right? So you've had a server failure within the DAG, you've had to activate a couple of copies, but you still have some passives on there for replication purposes. In this case, we actually see that because we've limited the number of max active copies, you actually get more memory per active copy. So we now have about 4.1, 4.2-ish gigs of RAM for all of our active copies, and the passes are in that 850 meg area. So, and these are just examples, right? They're not hard-coded, but I wanted you to get an idea of what your server might look like if you opened up Task Manager. And moving on, one of the big questions we always get is, how are we doing again? How's storage? How is 2013 going to save me more money? So let's talk about IOPS reductions that we've done again. Quick history of Exchange. If we go back over time, all the way back to Exchange 5.5, we had those lovely 9, 18 gigs SCSI 3 drives. We needed them to be as fast as possible, 10, 15,000 RPMs. Maybe you had a 25 megabyte mailbox, which, let's face it, that's the max message size in Office 365 today. So how far things have come. And then as we go down the line, things didn't really start to change much until we got to Exchange 2007. Then we saw the large jump in the capacity of spindles. We actually started to be okay with spindles that were about half the speed is what some of the deployments were. With 7,200 RPM SAS drive, fine. And a giant jump of 250 megs to 2 gig mailboxes in 2007. All right, 2010 continued the trend. Still 7,200 RPM, that was fine for a SAS drive. 2 terabyte drives were now commonly available, and we started to see the 10 gig mailbox happen. And once again, 2013, we expect 4 and even 8 terabyte drives to become commonplace during the life cycle of 2013. And we're still cool with 7,200 RPM drives, right? SATA or SAS maybe, depending on your deployment types and what you need, are both acceptable. And 25 gigabyte mailboxes are starting to be the norm. We even just created Office 365 to handle 50 gig mailboxes, so we've even doubled that. All right, so over time, what we're seeing is that we used to be very, very, very capacity constrained in a deployment. And now, because of the jump in spindle sizes, we're now I/O constrained. Oh, sorry, hold on. We used to be I/O constrained. Now we're really capacity constrained. That should be flipped. Because we're seeing that the larger and larger mailboxes are causing us to have fewer and fewer mailboxes per spindle because their sizes are getting so huge. Plenty of performance around the spindles, we just don't quite have the capacity. So drive sizes have gone up 800%, but really rotational speeds are going down, and random I/O is not really going up. In the last few releases of Exchange, we haven't seen random I/O go up terribly high, if at all, on the different spindle types that are out there, even though capacity is going way higher with much more dense platters within the units. Continuing on, some of the more interesting things that we're able to pull out of our data centers are annual CO2 use per user in kilograms over time. Right? We've actually got this now in the cloud down to where we think it's about 1.23 kilograms per user because of the fact that we're actually be able to give them these huge databases on really slower spindles that aren't sucking up nearly as much energy as they used to be. And this allows you to save in other areas that you might not normally think of, right? Everybody thinks of the hardware cost for, say, an Exchange deployment, but overall your data center costs also start to go down. Your cooling, your heating, maybe even your floor space, depending on your deployment type, all those costs start to be realized once you're able to get into these slow large spindle deployments. All right, and all these things are things that various vendors are doing all over the internet, right? We're not alone. Hotmail's doing this, Gmail's doing this, Google does this. You can see all the names there. This is the trend everybody is starting to move to if they haven't already. So in Exchange itself, what else have we done, right? So we've actually changed from having individual properties on messages to property blobs. So now if I need to read 10 properties on a message, well, I used to have to go and do 10 reads. Now I just read one blob. Blob might have 50 properties in it, even more maybe. But I'm only going to actually use 10 of them. But it's still one quick read to the disk. We get back every single property that we need in that property blob, and we're done. We've got the information that we need. Right? We've gotten rid of long value storage. I shouldn't say we've gotten rid of, but reduced it, so that when we are able to do, for the most part, very large sequential I/O when reading these messages from disks. We've moved the passive copy I/O up to a 100 megabyte checkpoint depth. It's no longer 5 megs as it was in 2010, which allows us to then reduce the passive I/O dramatically. In 2010, you might have seen that a passive copy might have used twice as much I/O as an active copy. Now they're getting down to roughly about the same, give or take a little bit. And our transaction log code has been redone one more time so that now we can actually do a really, really fast playback of logs, so where that 100 meg checkpoint doesn't harm us. In 2010, we had it so low because it took us too long to play back more logs, or I should say commit more logs to disk, or transactions really, not necessarily logs, commit transactions to disk so that we could then mount the database. Well, now that our transaction log code has been refactored, we can have a nice big fat 100 meg checkpoint depth on passive copies and databases as quick as we can. I believe in MSIT we're seeing numbers roughly about half of what it used to take to move a database from one server to another. So if it used to take us 30 seconds, it might be taking us roughly 15 seconds today. Comparison-wise, there are some trade-offs. So we see our database IOPS per mailbox drop, kind of in that 0.12, 0.16 area, depending on your user type. And I want to point out as well, the numbers here are based on Exchange 15, 2013, build 466. This is pre-RTM data. These numbers actually got a bit better towards the time that we released. Online and CAS codes over on the right-hand side, we've seen roughly 48% drop in IOPS for online mode users, 76% for cache mode users. These are going to vary deployment to deployment depending on your profile types. RPC latency, average RPC latency reductions between 18 and 41%. You can go down the line, right? But there's a few trade-offs. We use more megacycles. We're actually using somewhere maybe between 1.5 to 2 times as much CPU. And let's face it, if the last time you bought servers were 4 or 5 years ago, any server you buy today is already going to have that much more CPU in the newer architectures and processors they have. And we also use a lot more memory. But as we expected, memory costs are dropping daily, weekly. It's getting obscene how much money you can get for the same amount of money you might have spent 3 or 4 years ago. So while we do use more memory, we do use more CPU. The storage costs have still dropped significantly because of this. Right? So we've actually gotten down, again, depending on your profile types, roughly a 95.5% reduction in I/O all the way from Exchange 2003 to Exchange 2013. Right, so from 2007 to 10, you kind of saw that 50 to 60% reduction depending on user type, and you're seeing roughly 35 to 50% reduction again from 2010 to 2013 depending on your user type. All right, and what does this allow us to do? Huge mailboxes, right? Large mailbox size to Microsoft is something 100 gigabytes or larger. That's what we consider a large mailbox. And that's an aggregate, right? So that's your primary mailbox plus your archive mailbox plus recoverable item space. 1 to 2 years of mail minimum, somewhere in there is what we expect to see. The chart on the right-hand side, I believe, was a 75 kilobyte average message size. You can start to see, how much mail, 100 gigs really would be. So let's just say message sizes don't go up over the next few years. What would it take you? So 4 years is about 11 gigs. So you're looking at 8, 9 years of mail maybe before you get into 100 gigabytes. Is mail from 8, 9 years ago really relevant? Probably not. You probably want to start aging it off the system. And then at that point, you almost have an unlimited mailbox because as stuff gets really, really old, you're automatically deleting it. New stuff can come in. Increased worker productivity. IW means information worker. So that means that we spend less time hunting around in our various PST files, the one from last year and the year before and the year before that, which are probably stored in an unsupported fashion on a file server. Right? We can get rid of all those PST files, suck them into their archive, and have everything in one place. You can search all of it from OWA, search all of it from Outlook, from Windows, and be able to reduce the amount of complexity in your environment by having everything right there at your fingertips. It's all discoverable from a legal standpoint. Everything's nice, clean, in one place. And also the last one, hopefully I don't offend anybody in the list, but hey, it'd be kind of nice to be able to get rid of some of the third-party archive solutions so you're only maintaining one system as far as email content goes. If you haven't seen it, Outlook 2013 actually has an ability, it might be a little small to see, but you can actually say, yes, I want to use cache mode, but I also want to only keep a certain amount of my mail offline. So if I've got a 100 gig mailbox, I might only keep 12 months of that offline. I can move it up to 24 months. I could say, yeah, give me everything. But let's say you have something like, not the plug, but a Microsoft Surface, right? You've got the 32 gig model with an SSD drive in it, or the 64 gig for the Surface Pro, and you only want to keep the last year or maybe year and a half of mail on your server system to save on SSD space, crank this slider down to what you want, and your OST file is going to be much smaller than it would be if your whole mailbox was cached locally. Add in the fact that Outlook 2013 also, which doesn't seem to get a lot of attention, which I think it should, their new compression algorithms in their OST file in 2013 are about 50% better than what they were in 2010, or I should say twice as good, I guess. Because if you had a 10 gig OST file in Outlook 2010, if you install Outlook 2013 from scratch, that same amount of data would take up about 50, maybe 50 to 60% of the space. All right, I know we're coming up to our 1 o'clock here. I hope some folks don't mind if we go over a little bit. We'll try to keep it as little overhead as we can. So scheduled maintenance. One of the other things that we've done all over the place in 2013 is take our scheduled maintenance jobs, the ones that used to be, say, run from 1 to 4 in the morning, run from 2 to 3 in the morning, send out our quota notifications at 2 a.m., get rid of all that. Because what was that we were spending time doing tasks that weren't even actually doing anything in the end. Right? So what we do instead now is we have our time-based assistants, which will actually just sit and look at all the different workload management monitors in the server. How are we doing on CPU? How are we doing on RPC latency? All right, what do we look like? Are we healthy? Are we unhealthy? And when it sees the valleys and the performance curves, right, it should say, okay, we got resources available. We'll kick in these assistants and start to process some of our database maintenance or quota notifications, et cetera, to make sure that we're filling in the server, making it nice and smooth as, based on how much performance we're using over a day. Instead of just saying, look, we're only doing database maintenance from 1 to 4 in the morning and that's it. We'll just do it all day long as we have resources available to do it. So we don't harm the box by doing too much, and we don't let this box sit there twiddling its thumbs doing nothing. All right, and the quota notifications, they're actually a little smarter. They'll actually only fire when the user logs on, and will only send a notification once every 24 hours. Because let's say something like an educational customer. They might have 80,000 users that are students, and their students never log onto the mailbox because they might be forwarding their mail to an external personal account. So what does a mailbox that nobody logs into, what's good is it sending them quota notifications all the time, right? There's nothing in it really. So why are we even going to look at it? There's nothing happening. So we'll only actually do a quota notification when a user logs on and only every 24 hours, which is nice too, because then if they come back from vacation, it's the very first message right at the top of their mailbox when they come back. I can't ignore it. So modern public folders, completely re-architected for 2013. We threw out the book when it came to public folders and redid them entirely. There is no more public folder database. Public folders are now stored within what we call a public folder mailbox on 2013. It's just a new mailbox type. When you do new dash mailbox, there's a dash public folder you can do. And each public folder mailbox can have one or many public folders inside it. There is no specific limit on how many public folders can be in a public folder mailbox. The first public folder mailbox you create is what we call our hierarchy mailbox, or primary hierarchy. That is where all the rights for your hierarchy are stored, and then they'll be replicated out to all of your other public folder mailboxes. One change is that we're in a single master model now. So no longer can you have users making changes to public folders stored on different servers throughout the organization. They do get the benefit of being in a mailbox database, so they get the mailbox database replication model that we've had and made better in 2013, but you can't do the multi-master model anymore. So that is one change. You might have to move public folder mailboxes to be in a geographic region close to the team that uses them if you want to make sure they have the best performance possible. All right, so one of the best slides I've seen in the last couple of years. We've got all of our friends down below, and let's say Mr. Clown first wants to make a connection to their public folder mailbox to read the hierarchy, right? So he's got to find out, well, what folders are actually out there. So they connect to their home public folder mailbox first, which should be near their primary mailbox. And then we want to involve other characters in this animation. So Santa Claus, let's say, wants to get data that lives in a different public folder mailbox, right? So Clown has essentially told Santa, hey, you're going to open up the sales folder, and the hierarchy says, well, that's nice, but the sales folder lives on a different public folder mailbox. So then Santa goes off and gets the content back from the sales public folder, which is in a different public folder mailbox in a different database. Okay, everything's good so far. Now let's say the queen, right? So the queen wants to make some changes to a folder that she's in charge of. She wants to add or remove some permissions, maybe, to her public folder she's in charge of. And that change, even though it hits a public folder mailbox, let's say in server 3, that change will be intercepted and sent to the primary public folder mailbox where the only writable copy of the hierarchy lives. And then that writable version of the hierarchy will be responsible for replicating those changes out to all the public folder mailboxes so that all the users have the common view of the hierarchy throughout the organization. Another possibility, which we don't exactly show here, but it looks like we've got the guy with the funny hat on. If you have a public folder mailbox that gets full, just like a mailbox move request, you can actually do a public folder move request to move some public folders out to another public folder mailbox. So you're not limited, and you can't just say, okay, once I make my public folder mailbox and put my public folders in it, you're not locked in. You can always move them out to different mailboxes if you need to. I know that is a very high-level overview, and we didn't go through how to do the migration, but we could have an entire one of these sessions on public folders themselves. Certainly send back feedback to Josh if you'd like to see something along those lines. So the new search infrastructure. I'm going to go through this one a bit quickly, only because we need to get to the end for Q&A, which I enjoy. So we use what we call Search Foundation. This used to be called FAST. So Microsoft bought the FAST search technology. This is one of the areas that you now see it integrated. You see it integrated in Exchange 2013, SharePoint 2013. We're starting to unify the search methods across our various products. And let's get into the good stuff. So primer. So Search Foundation will have what we call the CTS and the IMS, Content Transformation System and Integration Management Service. Think of these as the indexer and the querier. That's the easiest way to think of it. And then there is also the content index, which sits on disk, that both of these will either put information into or take information out of. So we might have an incoming document, right, aka an email, may or may not have attachments on it. It hits the CTS, and CTS does a word break to basically pull out all the words that are useful as far as the search goes, changes them into an XML format, and then dumps them into the catalog itself. Later down the line, we'll have a query that comes in. The query parses out for the word list that is good for a search, forms the query, does a query against the catalog itself to pull the results back to send them back to the client. Very, very high level, but just to get you an idea of what it looks like. All right, so now in the search infrastructure, what does this look like? So on Mailbox 2013, right, we have a message come into transport. Now it's going to hit the CTS while it's still in transport. What's really cool about this is then it goes and puts it a property on the message itself and says, here, you've been indexed. Congratulations, we've already got the word list on there and the blob on there that the indexer needs. So by the time the messages reach the store, it's actually already been indexed. Store doesn't have to re-index it again. So we have a local delivery to store. We put the message into the database. We fire what we call a reliable event that tells search, hey, search, we've got a new message for you, the index. Well, CTS is going to fire again, but all CTS needs to do is read the blob off the message. It's already been indexed. And then put that into the index node itself, right? So we've cut down on the number of places that we index it. I forget the exact number, maybe I'll put it into the IM, but Ross and some folks had done an investigation and figured that over the lifetime of a message, we were indexing it something like 75 times, right? You might have a database copy that fails and you have to reseed it, or full volume fails and you have to reseed all the copies, and every time you've got, let's say you have 4 database copies, well, we were indexing it 4 times, once for each copy, and it was insane the number of times we had to index a message. So when it comes to replication, right, now let's say we have a different mailbox server, right, well, we're going to still do our log shipping over the other server as we normally would for mailbox replication. But now, when we need to index the information, we don't have to pull the whole message over and re-index it on the passive copy like we would in the past. Now we can just look back in the database on the other side and say, hey, give me that blob off the message again. I'll pull that over, and we'll dump it into our index file on the other mailbox side. So we're actually sending far fewer bytes across the wire to be able to index the item on the passive copies. I forget the exact number, but it's a drastic reduction. Search indexing does still happen across the MAPI network, though. I just want to make sure you're aware of that. It does not happen across the replication network. Okay. Transport. Again, we've split it out. It's no longer one service. Again, how can we react quickly and isolate failure zones. So we now have the transport service, the mailbox transport delivery, and the mailbox transport submission services. Transport itself is responsible for receiving and submitting all mail to from the organization. Also is where all the internal message processing, transport rules, content filtering, etc. take place. That's where the routing decisions happen, queuing decisions happen, and you'll see that there are now multiple queues on these servers, and also our SMTP extensibility for any third-party extensions. So let's take a quick overview here. So we've got our transport pipeline. You can see over on the left-hand side, we've got an SMTP receive, which could be from the outside world. It might also be from the mailbox transport delivery service. So the mailbox transport delivery service will take a message that a user has submitted, pull it up, put it into SMTP received, hits our submission queues, and then fires off into the categorizer and the routing agents as you're used to in previous versions. We'll create multiple delivery queues depending on where that message needs to go, and send it off either to a local delivery or remote delivery, or perhaps submit the message back to the database, or even it's just going to a different mailbox server since we do not allow the protocol crosstalk. More, come back. All right, the components themselves. I want to point out here at the bottom, the mailbox store. So whether it's the store driver itself as part of the transport delivery service, right? So store driver is now inside transport delivery, or whether or not it's the store driver submit process within the transport submission process. Those are the only two areas where MAPI is still used to directly talk to the mailbox. That's it. But because these processes live on the same mailbox server, we don't ever talk MAPI from server to server. Again, as I mentioned before, if a message had to be pulled out of the database, and then it can only be done by transport submission service on the same mailbox server where the database is mounted. We will not allow, let's say, mailbox transport delivery to deliver a message to a database that sits on another server currently mounted. Not allowed. So again, we do talk MAPI here for transport, but since it's on the same server, latency doesn't really matter. Everywhere else is SMTP from server to server. Okay. As we mentioned, so we come back here once more time, transport delivery and transport submission, responsible for whether or not we're going to deliver mail to or from the database. We've combined the mailbox assistance and store driver right into the delivery service as you saw before. We are still doing encrypted SMTP between servers as we did before, and also a TCP 465 is now used for internal traffic server to server. Local RPC for delivery to store. Again, it's the only place we use RPC within the product now. And, excuse me, we say that stateless does not have persistent storage mechanism. Well, that's true for like front-end transport delivery, which we talked about before. But on the mailbox server, there is still your mail.q database as there was in previous versions. Okay. Let's skip here. Let's get the service availability. And then we're almost done. So service availability improvements. Again, isolate, react as quick as possible. The whole idea is that failures are going to happen. We need to embrace them and just recover as fast as we can. There's always going to be things that are outside of our control. So we've talked about this before. All core functionality for a mailbox is served off the same mailbox server. We do not allow protocol crosstalk from server to server, which means if, let's say, a database has to fail from server 1 to server 2, the OWA process from server 1 will not be able to access that database. You're going to have to re-authenticate to the OWA process in server 2, which if you've seen any of our client access server in-depth presentations, which I'd highly suggest going to take a look at, you'll see that we are now able to reuse certificate encrypted cookies to re-authenticate you on the fly, even if your database moves between servers. Manage availability is our internal monitoring solution, where the Exchange servers are kind of monitoring themselves and each other to see how healthy they are, and recover to events that happen that we just determine that, you know what, either we can't recover from this or it's quicker to do something about it than try to have an extended failure that's going to degrade performance and make people unhappy. So let's take a look at what this means. So we've got our user outside, we've got our layer 4 load balancer, 2 CAS, and 3 mailbox servers in a DAG. All right, so we've got an OA connection that comes in, right? So we hit the load balancer, we hit CAS1, we've done an OA send, and CAS1 connects to mailbox server 1 where I'm mounted, to database 1, and performs the action. Now, let's say we have an OA failure. Okay, so all of a sudden we've got an OA failure on mailbox server 1. Managed availability is going to detect this OA failure, and then we're going to restart the service. So we restart the service. OA is verified as healthy, right? So that's all we needed. In this particular case, a restart of the service fixed us, and we continue on our way, right? We're able to continue doing OA sends, etc. All right, so let's say a little further down the road, we detect another failure. Okay, that's not good. So now we've had OA fail twice in the same box. We've detected it. We restart the service, but for some reason the restart of the service did not bring it back this time. There's something outside of our control that we cannot fix. Well, in this case, our responder would basically say, look, managed availability, move the database from one server to the other. So now if I'll go back and forth so you can see it. So go back 1, you can see database 1 is active on mailbox server 1. It's kind of that blue color. MA responds, moves the database over to mailbox server 2. In this case, later on down the road, the OA service might restart and is then healthy on mailbox server 1, which means if we need to, we could then move database 1 back to mailbox server 1 in case something happened on mailbox server 2. But in this case, OA is still healthy. Now the user has moved from mailbox server 1 to mailbox server 2 and carries on doing what they were doing before. So as mentioned before, monitoring plus high availability gives us the ability to say, you know what, stuff's going to break, but the user experience does not, because Exchange will sit there and monitor itself. It will restart a service. It might even bug check the box on purpose if it needs to instead of just having a very slow, degraded performance experience for users. Okay, transport, and I believe we'll be done. So transport HA improvements. We still have shadow copy, right? That was something that we started having in 2010. We made that a bit better. So let's go over to shadow redundancy and talk about that right now. So we started in 2010. Shadow redundancy was the idea that we always have 2 copies of messages stored on different servers while the message is in flight. And we would not remove one of those copies until we would confirm that the message has been delivered. Okay, this carries forward from 2010 to 2013, except in 2013 we no longer actually have to purposefully forward the message along from server to server twice to make that shadow copy. We'll actually be able to receive the message on the mailbox server, and then the mailbox server will send a copy of that message off to a different server, but the first server that got it will make the delivery wherever it needs to go, let's say to its own database. So it does remove some of the hop counts that a message has to make before it is delivered. Each server does regularly heartbeat one another to see if that they are alive, healthy, and the server can tell you, yep, okay, this message has been delivered, so you can go ahead and mark that shadow copy is no longer necessary, and then keep it in something we call safety net, which is coming up next. And if necessary, what we call the primary server, if we have a primary server failure, which means that the message that had the database on it and the first copy of the message fail, well, the shadow server is able, after a period of time of pinging the other one and saying, oh boy, he's not coming back, something's wrong, self-promotes itself to the primary message, redelivers the message to the now active database copy to make sure that message is delivered. Something that is new is we added something called reject on shadow failure. So if you want to make sure that every message is protected in flight, no matter what, and is never accepted if we can't promote it to a shadow copy, you could turn on reject on shadow failure. So if you turn on reject on shadow failure, if for some reason you can't make a shadow copy of a message, you'll just reject it. You'll tell the sender, sorry, try again. Because maybe you've had so many messages go off, so many servers fail and go offline, you can't protect this message, and you want to make sure you have 2 copies of it. Reject and shadow failure, we suggest having at least 4 mailbox servers for this to work. This allows you to have a server down for maintenance, right? Now we're down to 3 servers. It allows you to have a server fail that was unexpected. Now you're down to 2 servers, and still have the ability to keep that message with shadow recovery, shadow copy in place by having the 2 servers that are left. If you only had 2 servers and you turned on reject and shadow failure, well, if you took a server offline for patching, you would start rejecting 100% of the mail in your org because there's nowhere to make a shadow copy. Okay. All right, and below where it says messages are made redundant on servers within a DAG stamp group or site. So if you have a message that comes into DAG1, we will only make the shadow copy of that message on another mailbox server in DAG1. we'll actually prefer a server in a different AD site on purpose, so that shadow copy is in a different AD site and give you physical geographic separation of those two copies in case you were to lose an entire data center. You can change it, make it prefer local, that's fine, but it will prefer remote out of the box. Okay, safety net. So safety net is an enhancement that actually came from Office 365. This is something we ran in Office 365 even when we were still running Exchange 2010 code. The idea of safety net is that we're not just going to delete those shadow copies once we're done with them. We're going to actually let them hang around for a while. Out of the box, you'll see safety net is configured for 2 days at a time in an on-premises 2013 deployment. What this allows you to do is that if you have a lossy failover somewhere during that time, we can then reach out to safety net and say, well, we've had a lossy failover. Please resubmit all the messages that happened to this database during this amount of time. And safety net will say, okay, no problem. I'll redeliver everything I have, and you'll be able to get back every message that was sent via transport in the last 48 hours. Now, this can't help things like calendar items that a user puts in directly or a contact item they put in directly, but it gives you guaranteed delivery of the message itself. You could also use this with a lag copy if you want to. You might have a lag copy with a 3-day lag on it, which then we'd say your safety net copy should also be 3 days. Lag time becomes the minimum time for safety net. So if you do use lag copies, make sure your safety net is configured to at least the lag time. It can be greater too if you want it to be. And if you know that, hey, you know what, it takes us about let's say an hour to activate our lag copy because we have to play through so many logs, you can actually say activate the lag copy, ignore the logs, and use safety net. And when we activate the lag copy, safety net would automatically kick in, redeliver the last 3 days of mail, and you'd have all the mail back without having to play back all the log files. So the benefit there is your lag copy comes online super fast, right? So you've got user processes running again. The users can access their mailboxes. They can keep getting new mail flow from the internet or from other partners, etc. And then over the next few minutes, safety net will start to deliver all the messages they got in the last 3 days. This will not protect, like I said before, contacts they put in or other changes that happen to the database outside the transport pipeline, but you could get a lag copy online very, very fast, and then they'll start to see their mail trickle back in again that they got over the last few days. All right. So key takeaways, and then we'll go to the Q&A. I know we've gone over by 15, 20 minutes. I hope you'll forgive me. So 2013, we have the new building block approach, right? And I'll repeat again, we believe the multi-role servers, CAS plus Mailbox are the way to go. It greatly simplifies our upgrade and interoperability, so there's no need to juggle, as it says there, CAS, Hub Transport, Mailbox, install order. You could theoretically upgrade your mailboxes from, let's say, CU2 to CU3 when we release it, and then come back and update your CAS after the fact if you're doing single role servers. This makes it a lot easier without having to juggle things back and forth as far as administrative upkeep goes. CAS role, again, simplifies the network layer. We don't need layer 7 load balancers anymore. They're still valid, though. If you have them and invested money in them, you can keep on using them. That's fine. They're just not a requirement. We proxy and authenticate everything on the CAS role, and then also provide you the load balance SMTP solution. And from there, we'll skip our little summary here because I'll admit I'm not a great marketing guy, and open it up for Q&A, Josh. So let's see what we've got. Ooh, right, that is a very small slide bar. Lots of chatting going on.
Yeah, we had a lot of questions coming in. So yeah, if you have a question you need it answered, feel free to do so. I'm going to ask a few survey questions real quick.
Okay.
And then, Brian, I'll just leave this open and people can stay as long as they want or as long as you can, and then
Yep.
I'll leave it to you to end it whenever.
Sounds good.
So yeah, we can get started. Thanks again for the presentation, and thanks for joining, everyone.